Linear Programming, the Simplex Method. Hi, we are the Team 3. In this video, we are going to focus on linear programming and the Simplex method. Most realized problems with formulating as linear programming model have more than two variables and therefore need a more efficient method to suggest an optimal solution for such problems. The concept of Simplex method is similar to the wrapping method. For linear programming, problems with several variables, we may not be able to wrap the phase region. Simplex method is a standard technique in linear programming for solving and optimization problems, typically involving a function and several constraints, expressions, and inequalities. The inequalities define a polygonal region, and the solution is typically at one of the vertices.
Characteristics of Simplex method. The use of the Simplex method to solve a linear programming problem requires that the problem be converted into this standard form. The standard form of the linear programming problem should have the following characteristic. 1. All variables are not negatives. 2. All the constraints should be expressed as equation by adding slack, surplus, or artificial variables. 3. The right-hand side of each constraint should be made non-negative. This is done by multiplying both sides of the resulting constraint by 1. 4. The objective function should be of the maximization or minimization type.
Slack variable and surplus variable. The term slack applies to less than or equal constraint, and the term surplus applies to greater than or equal constraint. If a constraint is binding, then the corresponding slack or surplus value will equal 0. In optimization problem, a slack variable is a variable that is added to the inequality constraint to transform it into an equality. A slack variable represents unused resource either in the form of time on a machine, hours, money, warehouse space, etc. Since these variables don't yield any profit, therefore such variables are added to the objective function with 0 coefficients. Likewise, what is a surplus variable? A surplus variable refers to the amount with which the value of the solution exceeds the resources utilized. These variables are also known as negative slack variables. In the objective function, it carries a 0 coefficient. In order to obtain the inequality constraint, the surplus variable is added to the greater than or equal to the type constraint. The artificial variable refers to the kind of variable which is introduced to the linear programming model to obtain the initial basic feasible solutions. It is utilized for the inequality constraint and for the greater than or equal inequality constraint.
Standard form of linear programming with Simplex method. 3 types of additional variables, namely slack variables, surplus variables, and artificial variables, are added in the given linear programming problem to convert it into the standard form for the following reasons. First, these variables allow use to convert inequalities into equalities, thereby converting the given linear programming problem into its standard form. Such form will help in getting solution of the linear programming problem. Second, these variables help decision makers to draw economic interpretation from the final solution of the problem and make the best decision according to the objective. Third, these variables are used to obtain an initial feasible solution represented by the columns of the identity matrix.
Simplex method using solver. Let's take an example and understand how we can solve Simplex method using solver in Excel. This is one of the exercises that we solve in class. The first step in linear programming is to develop a mathematical representation of the problem. where x1 equal to number of business courses, x2 equal to number of non-business courses. Now, the mathematical model of the objective function is minimizing c equal to 120x1 plus 200x2. To write the objective function in Solver, it's necessary to apply the formula sum product. For this, we must put the sign equal to and write sum product. Then select the black cells where the values of x1 and x2 are located. Put a comma and select the cells of the objective function. In this problem, we have 4 restrictions, which are presented in the table below. In the constraint table, we have a right side and a left side. On the left side, the values of the constraints are placed. While on the right side, we must use the sum product formula. Select the cells of the variables, put a comma, and select the cells of the constraints. Having implemented the mathematical model in the table, we can use Solver to find the optimal solution of the problem. Go to Data, Analysis, and click on Solver. In Solver, we need to define 3 key components of our model. First, we need to define an objective cell. This should correspond to the cell that represents the objective function. Second, we need to define the variable cells. This should correspond to the cell that represents the decision variables. Since our objective is about minimizing, we have to select min. We need to define constraints. This should correspond to cells that represent the various constraint functions in the mathematical model. First, select Add, and then in color reference, we have to select the left side in the table. In this problem, we need to use the sign less than or equal. Then, in restriction, we have to select the right side in the table. Now, we need to indicate that variables x1 and x2 should be non-negative. Since we are using linear programming, we select Simplex LP as the solving method in Solver. Once these input parameters have been defined, click Solve to instruct Solver to solve the problem.